Hi, I just thought I'd show you how to divide a complex number by another complex number. So here we have 2 plus 5i, and it's divided by 7 plus 4i. So both of those are complex, and it creates a difficulty. So what I do is, I would like the denominator to be only a pure real number. And I can do that by extending this fraction. And what I want to do is I want to extend it by something called the complex conjugate of 7 plus 4i. If you remember when we had square roots in the denominator and wanted to rationalize the denominator, we did a similar trick. So I'm going to multiply this whole fraction by 1, and I will write the number 1 in this particular way. I write it as 7 minus 4i divided 7 minus 4i. Which means that I'm gonna have on the on the numerator, I'll have 2 plus 5i, everything in brackets, multiplied 7 minus 4i in brackets, like this. And in the denominator, I'll get very much the same thing, but we can see here I have 7 times 7, that's 49. 7 times minus 4i, and then 4i times 7. Those two will cancel, which is of course why I choose this particular thing to multiply by. So my next will only be minus 4i squared. And this will turn out to be, of course, real. So here I'm using FOIL. 2 times 7 is 14. 2 times negative 4i is minus 8i. 5i times 7 is 35i. And 5i times negative 4i is minus 20i squared. And here I'll have 49 minus 16i squared. But this can be simplified. So I'll have, starting with these two terms, they're both imaginary terms, and as such we can just merge them. So 35 minus 8 is 27. So it will be 14 minus 27i. But what about this one? Well, I squared is negative 1, so minus 20 times negative 1 minus negative 20, so plus 20. And note that it's the real number 20. Here, I squared is negative 1, so it says minus negative 16, so 49 plus 16 equals 49 plus 16, I should do that quicker, that's 65, isn't it? 65, yes. 14 plus 20 is, so in the end we have 34 minus 27i, everything divided 65. Or if I prefer, I can write it as 34 over 65 minus 27 over 65i. And writing it in this way emphasizes that I now have a real part and an imaginary part, as all complex numbers have. With different numbers chosen, there might be simplifications going on here, but not always. But so this trick, it's a method, and it works because if you multiply a complex number by its complex conjugate, same real part, but opposite imaginary part, then the result, because of cancellation of the middle terms, will always be a purely real number. And obviously I think you should convince yourself of this, by doing these steps, possibly breaking out the 7 plus 4i multiplied 7 minus 4i. The complex conjugate we sometimes denote with a star. So if z, which we often call complex numbers, equals a plus bi, then z star, the complex conjugate of z, equals a minus bi. So this is useful as a method for solving division, for solving some other tasks, and you will need it for the tasks that you got on the lesson. Thank you.